Hi there, this is Math 6, Unit 7, Lesson 12, Constructing the Coordinate Plane. Alright, so here first of all we have what's called English winter. It says the following data were collected over one December afternoon in England. And so you have the time afternoon, so this is going to be like the 12 o'clock hour for noon. And that's 1 hour after noon, 2, 3, 4, 5, and so on. The number of hours after 12 o'clock noon. At that time, those times, they recorded the temperature in degrees Celsius. You have 5, 3, 4, 2, 1, -2, -3, -4. So you can see that it's a temperature here, and as the day goes on, as it goes further away from the noon time, the temperature seems to decrease until it gets to a relative low of -4 degrees Celsius. The first question it wants us to look at and consider here, it says, which set of axes would you choose to represent these data? So knowing that this is the data we're talking about, it wants to know which one of these axes, A, B, and also, I'm going to try if I get it on here for you, C, would you use to represent this data? Now my C was on a different page, that's why I just ripped it off here and put it on there. So I'm going to just stick it right there for now so you can kind of see what we're talking about, A, B, and C. Which one would you use? And I want you to explain your reasoning. So as you look at these here, what we're really paying attention to is kind of the scale for these, the axes, for the X and the Y. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have the time afternoon, and each line represents one different hour. That's the same here, although you can see they went ahead and only numbered every other one, but it's still one line per hour. Over here on the X, we can see that it's measuring time on the lines by 10, 20, 30. So when you think about this one here, if we're doing time after noon, all the data is going to be between 0 and we went to 8, so somewhere around here. So all the data is going to be just on this side of that line. So we're not even going to use any of this space at all in this chart. When we plot those points on there, nothing would ever be on that side. So that's a whole lot of wasted space there. And it also means that on all of our points, for the temperature is going to be just in that little rectangular area. Alright, so this one so far doesn't seem like a good one to use, but let's see what else we can look at. Here we have the temperature. The temperature here we see goes from 5 to -4. In this case, the temperature allows us to go to 5, but there's no negative down here. It doesn't extend to the negative side, so all these values we would not even be able to put on that graph. So A is not going to work for the temperature, right? Now it would definitely work here. We can go +5, we can go down to 4. So far B is working well. And then when you look at this next one, alright, the C, we're going from 5 to 4, which means 5 is half of this, so 5 is going to be there, which means we don't even use that space there. And we're going to 4, so we don't use this space here. So the only part of the graph we'd actually use would be right there, right? So you'd have your choice of graphing things over here, you know, for example, 0, 5, 1, 3, 2 at 4, 2 hours at 4, wow, so it went back up a little bit, weird. 3 is at 2, 4 is at 1, 5 is at -2, 6 is at -3, 7 is -4, and -4, right? So if you're plotting the temperature like this, you would have something along these lines, right? And if you did that in the same space, you'd have something similar, but it would be, you know, really tight. I'm just sketching it here, right? Something like that. So the question is, which one would you want to use to help you make some predictions about the weather in England in that December? This itsy bitsy tiny chart, or the one that makes a little more sense because you can see where the data points are actually going to be? I would suggest using B. It makes the most sense. A just would not work because it doesn't include the negative part, and C doesn't work because the grids are just too far apart. It would work if you're looking at time every, you know, and by minutes, 10, 20, 30, 40 maybe, or a longer period of time. But for the numbers just don't fit well with that. Yes, you can make it work, but it's not ideal. And that's what they want you to be seeing there with this lesson. So then it says, explain why the other two set of axes did not seem as appropriate. And we've kind of talked through that already, so hopefully we're okay on number 2 as well. Talking through why it works and why they don't work. B is the best one. Alright. Activity 2 for lesson 12 says here are 3 sets of coordinates. For each set, draw and label an appropriate pair of axes and plot the points. So to draw an axis here, what we can do is we can draw an x-axis over here. We can draw a y-axis here, okay? And then of course we could label them if we chose to. We could say this is going to be, in our case, 1, 2, 3, 4, or -1, -2, -3, -4. Going up here we have positive 1, 2, 3, 4. And down here we have -1, -2, -3, -4. I should have paused real quick. I got ahead of myself. The reason I'm going to make mine just increments of 1 is when I look at the x values, what x values do I have? I have 1, I have a 3, I have a -5, and I have a 0. So putting them in order, I have x needs to go from -5 to 3 on a scale, right? So here's -5 as well. So for me, I need to make sure I can be inside of this range, right? Here's -5. I'm going to go on the outside of it there. -5 all the way to 3. That's the space I'm working with. On the y side, we're talking about we have a 2, we have a -4, a -2, and a 2.5. All right. So in this case here, I might consider something like I need to go all the way down to -4, so I know I'm going to be over here somewhere, and I have to go all the way up to positive 2.5, so somewhere about here. Meaning, for my graph, it's going to be inside of this space, and it's going to fit just fine inside that space right there. Okay? If I wanted to, I could do an orange just so you can kind of see it's going to be inside of the orange box there. So when I plot it, we have 1, 2, so it's going to be here. We have 3, -4, so right there. We have -5 and -2 there, and 0, 2.5, so somewhere up there. So those are my points, and you can see they all fit inside of that. Something different you could have done, perhaps, is you could have said, let's make each one of the lines a half, because you're dealing with a half point there. That would have been fine. You would have had a little different thing. You might have had to slide it over a little bit to make it work, but part of doing this is just experimenting and getting good at visually seeing ahead of time what you're going to have to be able to construct. So let's look at letter B. Letter B are x values once again. What are our x values? We have a 50, a 0, -10, -35. So I needed to go from -35 all the way to 50, right? That's my range of numbers for the x. For the y values, I have to go from, I have a 50, a 0, -30, 40. So my smallest is -30, and I have to go all the way to positive 50. So I don't have 50 lines there to make that work, do I? Okay, that's not going to work too well. But I could either put these in increments of 5s or increments of 10s. Now let's think this through. If I made it increments of 5, how many would I need to get to 50? Well, 5 times 10 gets you to 50. So I would need 10 lines, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in order to get from 50. If this is 0, that becomes 50. But I have to worry about the negative part. So if I did 5 this way, I have to go 7 more. 1, 2, 3, 4, 5, 6, 7. Looks like it could work. So I could go by 5s. That would work fine. I could also go by 10s, and that really is up to you. What is it that you want to do? Do you want to go by 5s? Do you want to go by 10s? You have to decide that, right? But wherever I draw this x line at, I have to pay attention to where I draw the y axis at, because if I go too high or too low by 5s, then I might run out of space. So I'm going to go ahead and go by 10s just because I think it's just going to be a little bit easier for me to go by the 10s. So I'm just going to cut mine in half because I know it's going to fit if I just do that. So I'm going to cut it in half. I'll go like this. That's fine. There's my axes. And I'll make these equal to 10. So this becomes 10, 20, 30, 40, and 50. And this becomes 10, 20, 30, 40, 50, -10, -20, -30, -40, -50, -10, -20, -30, -40, -50. Alright, so my first point is at 50, 50. So you can plot that right there. I have a point at 0, 0, -10, -30, so there. And then -35, so halfway between 30 and 40, and 40, right there. So I can definitely get all those points plotted just like that. Not a problem at all. Again, you could have counted by 5s. That would probably work on this graph. you'd probably have to kind of start it over here to make that work, or a little further over, but again, it's up to you. What do you feel like doing? Okay. Now the next one is dealing with fractions. Oh boy, how do you plot fractions? Okay. One thing you want to look at when you look at the fraction ones is it's helpful if you have a kind of a common denominator here in this case, because that'll allow you to break everything up the same way, right? So everything seems to be in fourths, with the exception of the half. So how could I turn a half into a fourth? I multiply it by 2 over 2, I end up with 2 fourths. So this fraction here can actually be written as 2 fourths, and this one can be written as a negative 2 fourths. At this point I have fourths everywhere. So what I'm going to do is I'm going to draw a line right down the middle again for my y-axis. I'll go right across this way for my x-axis. And here's what I'm going to do. I want to make each one of these a fourth. So 1 fourth, 2 fourths, 3 fourths, and this is going to actually be my 1. Does that make sense? 1, 2, 3, and this is negative 1. And then 1, 2, 3, positive 1. And then 1, 2, 3, negative 1. Meaning this is going to be a 1 fourth here, this would be a half, and this would be 3 fourths. And I could write those numbers all over if we chose to. I'm not going to, because this one's going to be a half. So now when I plot this out, if I go 1 fourth to the right, I'm going to go here on x, and the y value is 3 fourths. So I go 1, 2, 3 of the fourths. Okay? So again, it's a fourth. Why? Because this is the 1. The 1 goes here to here. That's the 1. Right? And I've broken up the 1 into fourths. Okay? Just to get you an idea there. So the negative 5 fourths, then I'm going to go out 1, 2, 3, 4, 5, and then the y value is at 2 fourths, so 1, 2. So that one's there. Negative 1 and 1 fourth. Now again, this means I'm going to go out a whole 1 and another 1 fourth. So same spot, but this time I'm going to go down 1, 2, 3 fourths. So right there. And then we'll do 1 fourth here and down a half. 1, 2. A half is 2 fourths. Okay, so you could label those definitely. 1 fourth, comma negative 1 half. You could do 1 and 1 fourth, comma negative 3 fourths. And usually you label your points. I did not do that on the other ones, I apologize. Alright, but that's just kind of what you would do to show what those points are. So now I've plotted them, I've labeled them, and I chose to make each of my grid lines equal to just a fourth. So sometimes we make it work with just a scale of 1. We did one with a scale of 10, one with a fourth. And that's the big thing. Your axes and labels are going to be different each time depending upon essentially what scale you decide to use to determine your x and y lengths on that grid. Okay? And the way you do that is going to affect whether your plots are closer together, farther apart, or don't even fit on the coordinate plane at all. Okay? Alright, let's look at activity 3, which is kind of a fun little activity here to practice working with the coordinate grid. It says here's a maze on a coordinate plane. The black point in the center is 0, 0. So this is our 0, 0 point right there. So we can mark that up there. That's our 0, 0 point, right? Lovely. The side of each grid square is 2 units long. So everything is 2. So all the grid marks are 2 units long. So I'm going to go ahead, I'm going to draw this x-axis through there just to help me visually see what's going on. I'm going to draw my y-axis through there, again, just so I can see what's happening here. Okay? And everything is 2. So this point right here is 2. This is a 2 and a 4, 6, 8, 10, and out here is 12. So you can see over here this is the 10 on the x, which matches there. So just make sure you got an idea what's going on. It says enter the above maze at the location marked with a green segment. Draw line segments to show your way through and out of the maze, and label each turning point with a letter. Then list all the letters and write the coordinates. So we're going to start right here at point A, which is at, in this case here, we see this is 10. Right, we're going out 1 or 2, 4, 6, 8, 10, and we're out one more, so that's 11. So A is at point negative 11, comma, and then for our y value, we're 2, 4, 6, 8, and 9. So we're at negative 11 comma 9 is where A is, and you can see on the maze they went to this point and turned. So we label that B, and at B our X value has moved this way. So now where are we in relationship to that orange line? We're 2, 4, 6, 7. So we're negative 7, but notice our Y value stays the same because we didn't go up or down vertically, we just went across. Now when it goes down this way to C, in this case our X value stays the same spot, so we can keep this at negative 7, but our Y value definitely is a different spot. So let's count it from the X axis, 2, 4, and one more makes 5, and we're there. So now we need to continue going through this maze. So let's go to point D. Where do you want to go next? Well, I'm going to take this and I'm going to go all the way over to this opening right there. That's where I want to go. So call that D. Now where is D? D is located here, which is over at 1. Okay, and the X value is 1. And the Y value, though, is still where it was before. We went straight across, so it was 5 here. It's still 5 there. Alright, now we're going to go down. We'll go right there. We'll call that point E. And point E has the same X value, but the Y value is going to start from here. We go 2, and one more is 3. Okay, then we're going to turn. And go there. And we'll call that F. Oops, F. And for F, again, in this case here, the Y value stayed the same, but our X value changed. So we're this far from the Y axis. We go 2, 4, 6, and one more 7. So 7, 3. All right. Then we're going to go all the way down to here. Call that G. And for G, our X value stays the same, so it's still a 7 from the last one. But our Y value is different. Now we're down here, so let's count this up. We have 2, 4, 6, 8, and one more is 9, but we're going down this past below the Y axis, so it's negative 9. Okay, we're going to go this way. And stop there at H. Now on H, our Y axis is exactly the same, our vertical is the same, but our X changed. We went over 1, so negative 1 there, and then we're going to go ahead and go up to there. That's I. And our X stayed the same, but our Y value, we're going to go 2, 4, and one more is 5, so negative 5. Then we'll go this way for J. And for J, our X value changed, so we go 2, 4, and negative 5. And the Y values stay the same. And then we go out at K. And at K, our X value stays the same, but our Y value is now 2, 4, 6, 8, 10, 12, 14, and one more makes 15, negative 15. Alright, so quite the little maze there is what you're doing. You're turning at each point and seeing what those points are going to be. It helped me to just visually show where that X and Y axes were going to be to help me count away from there to get the other points. So the next question says, choose any two turning points that share the same line segment. What is the same about their coordinates? Okay, so let's say, for example, if you looked at J and I, okay, those are two turning points. When you looked at J and I is at negative 1 comma negative 5, and J is at negative 5 comma negative 5. We see in this case here that the Y coordinates are the same. This is also a horizontal line, isn't it? So a horizontal line means that they have the same Y coordinates because they're on the same Y part of the Y axis, right? It's going right across there, so they're on that line like we talked about before. So these have the same ones. You could do the same type of thing with a vertical, F and G. With F and G, what do you find? They have the same X axis, okay, or the same X coordinate because they're on that same vertical line there. All right, pretty cool. And I think that's really it for today. Let me double check my notes. Yep, let's take a look at our summary, and then we'll let you work on your homework together. So summary real quick says, the coordinate plane can be used to show information involving pairs of numbers. When choosing the coordinate plane, we should pay close attention to what each axis represents and what scale each uses. So pay attention to what the axis is talking about and the scale, right? So you're not having too large or too small of a graph to show the information you want to show on the coordinate plane. Okay, and they give an example here about plotting temperatures in Minneapolis one evening. Again, you can see that the time is going from -4 to 3, so you don't want to have something that's going to go like to tens and hundreds on your grid. You can keep it really small. And the temperatures are also positive and negative, so you want to make sure that you're on both sides and can use the whole graph there. So you'd have to decide what you want to have for your x values and what scale you want to use there. Okay, so there's an example here what that might look like. If you wanted to plot this way, a good example for that temperature one, again, just plotting by ones and then making it work to show the temperature, and you can plot the points and they fit well. Okay, so just take some time when you make your scale. Don't be in a hurry, and it's okay to erase and start over if you need to. All right, I'm going to pause there, let you do your homework. We'll come back and check it together in a little bit. All right, here's our homework for Math 6, Unit 7, Lesson 12. Draw and label an appropriate pair of axes and plot the points. So for these points here, one thing I noticed is they all are dealing with fifths, right? So they're all fifths. So what I want to do is I've decided to take an axis like this, an x and y, and for the most part it's all less than 1 with the exception of this one, which is 1 1/5 on the negative side. And so to me that meant if I thought about a grid, I'm going to go out and make each one a fifth. So 1/5, 2/5, 3/5, 4/5, and this becomes my 1. Does that make sense? I'm going to go 1/5, 2/5, 3/5, 4/5, and that's my positive 1 there. I have 1/5, 2/5, 3/5, 4/5, -1 here, and 1/5, 2/5, 3/5, 4/5, and -1 here. I'm going to go one more because of that one there. So knowing that every little one of the boxes for me is a fifth, that's going to allow me to get everything to fit here. So when I go 1/5 for the x value, this is 1 of the 5, right? So 1/5 is here, and 4 is up 1, 2, 3, 4. So I plot that there. -3, 1, 2, 3 fifths, and up 2, 1, 2 goes there. -1 1/5, here's a whole -1, and one more 1/5 is there, and down 1, 2, 3, 4 fifths here. And then finally 1/5 there, and -3/5, 1, 2, 3 goes right there. And again, you could label all those to be more clear about which point each one is. I'm sure your teacher would appreciate that to show that you're not just putting dots all over the place. Okay. Again, if you use grid paper, it's even easier to show that you're on those lines. I just kind of visually saw that about right. You don't need to draw all the grid lines, but graph paper certainly helps, doesn't it? Right? Just don't have any with me today. All right, number 2. Diego was asked to plot these points, -50, 0, and so on. What interval could he use for each axis? Okay, so you're talking about, because the x has values of -50 all the way, actually -250 up to 350, has a range of -250 all the way to 350. That's a big range there. And y has a range, we have 0, 100, -100, 50, 0. So we have -100 all the way up to 100. We're not going to want to use ones, right? That's going to be too small. Okay, you could definitely use intervals of 100, but that might be maybe a little too small or too large. Maybe because you're dealing with a range here, the y is going. You could use maybe, I would probably use an interval of something like maybe 50. Okay, that could work well, because again, if I'm dealing with the y-axis, if I went 50, this is 50, 100, and I'm already done. 50, 100, and I'm already done. So I could use 50. You might want to consider 25 to just show the graph being stretched a little more. Okay, on the x side, because I go 350, that's going to go further, right? 50, 100, 150, 200, 250, 300, 350. That would extend further out that way. So 50 is not bad for that in that case. 25 might be a little too much then, right? And then over here, negative 250, same thing. So it's going to get spread pretty far. Anyways, that's the idea. I would probably go with a 50. Just makes the most sense for me, but you need to explain your reasoning for which interval you would use. Definitely don't use 1s or 5s or 10s. I think it's just way too small. 25 might be too small too. I think 100 is just too big. It just really is. But it's up to you. Name 4 points that would form a square with the origin at its center. Okay, a lot of variety answers here. It can really be many, many, many different things. It's going to be a square if they're using the same numbers. Now, because the origin's the center, they're going to have the same numbers everywhere. So let's say you went with 1, 1, 1, 1. If I plotted a point at 1, 1, and plotted a point over here at negative 1, 1, and a point over here at negative 1, 1, and a point at 1, negative 1, I would form a square, wouldn't I? Okay? So as long as the numbers are the same and then, you know, opposites as they need to be in the right quadrant, you're going to form a square. So you could have said 1s, you could have used 2s, 3s, hundreds, it really doesn't matter. As long as the x and y numbers are the same, the digits you use and just have different values for positive or negatives, you're going to get a square. So when I graph it, it looks like that. That's what I did for just the 1s. Alright, which of the following changes would you represent using a negative number? So a change being a negative, a decrease of some sort, and explain then what a positive number would represent in the situation. So a loss of 4 points, that would be a good one to use a negative number for. Why? Because you're losing 4 points. It shows a decrease of 4 points. A positive number in this situation would be what? That would be like something like making 4 points, or making an increase, or making just points in general, right? So a negative is losing points, a positive is gaining or making points. A gain of 50 yards, that's a positive one, so we wouldn't use that. A loss of $10, that would work. That's a negative number. That'd be like negative 10, right? So when you lose money, it's negative there. And what would the positive be? It'd be like earning money, or earning or making money would be what the positive would be there. Okay? Elevation above sea level, again, that's above, so it's already positive. We wouldn't use that there. So let's go with A and C as the best things to use. Alright, and our next one, 5. Jada is buying notebooks for school. The cost of each notebook is $1.75, right? So it costs $1.75. Write an equation that shows the cost of Jada's notebooks, C, in terms of the number of notebooks that she buys, right? So let's say if she bought one, right? If she bought one notebook, you would take 1.75 and you multiply it by 1. That's the notebook, right? And that would give you the overall cost. So in terms of an equation, the cost of the notebook is going to be equal to the price of one notebook times the number of notebooks that she buys. Okay? So then when we look at which following could be points in the graph of your equation, you're thinking about, well, this is our y and this is our x. Think back what we did before. Okay? And as a result of that then, if I do 1.7 is my x, can I multiply a number and get 1? No. Again, just think realistically. If I'm making a table, if I buy one notebook, it's going to cost $1.75. If I bought 2 notebooks, I do $1.75 times 2, which is going to be what? Well, that's going to be $3.50. Okay? So again, just kind of thinking about a table, what would you do there? Okay? So if I do 3, again, same idea. It'd be 3 times $1.75. This is going to continue to increase like that. So my x value needs to be the number of notebooks I'd buy. Probably not going to buy 1.75 notebooks. If I bought 2 notebooks, 2 times 1.75 is $3.50, so that would work. 5. Well, what is 5 times $1.75? It actually is $8.75. Am I going to buy 17.50 or 17 and a half notebooks? No. And this one here, before you get ahead of yourself, is 9 times 1.75. That actually equals 15.75. So this one would not be a good answer either. Okay? So what you probably want to show is how you multiply 5 and then multiply 2 to get the y values there and why that doesn't work. And finally, number 6, a cornfield has an area of 28.6 acres, requires 15 million gallons of water. About how many gallons of water per acre is that? So our water per acre, we have 15 million taking care of 28.6 acres. And what we're trying to find out is how much is this per 1 acre is the idea. So you could do the division, you certainly could do that, 15 million divided by 28.6, but again, we're wanting to know about how much. You're estimating an approximation of what that's going to be. Okay, so thinking about what that's going to be, 15 million, in a sense, divided by 28. Okay, you could think of it a couple ways to think about it. You can think about 15, 1, 2, 3, 1, 2, 3, divided by more like a 30. Okay, a little bit nicer number there. We get rid of some 0, a 0, 0 there. And then I could think 3 goes into 15 how many times? 3 goes into 15 5 times, with how many zeros left over? 1, 2, 3, 4, 5. So what do I have? I end up with 5,000, which matches choice C. Again, you could do it with a calculator. Just some simple ways to estimate there. Just turn that to a number you like. We got reduced a little bit, and then we just did division. 3 went into that. A little nicer to work with than 28.6. If you did a calculator, you probably got something like 524,475.524, and you went, that's the closest. But it just wants you to get an about anyways. Okay, that's it for today. Have a great day. We'll see you next time.